This week we begin our unit on functions. So we're going to go through some guided notes here and learn a bunch of vocabulary for this unit, as well as some examples. A function is a relation where each x value or input, you could say input, produces exactly one output, which is also your y value. That's the definition of a function. Inputs are your x values, outputs are your y values, as they depend upon the input. So the output depends on the input, okay? Input values are our blank, output values are our, so input values are our domain, and output values are our range. So a whole bunch of words here. Identify it with ordered pairs. So functions are a situation in math where the input that you pick produces one output. All right, so you could have a set of ordered pairs like we do here. We're looking right here. And if every input value, the x value, has a different output y value, then you have a function. So let's look at example 1. Let's underline the input values. These are your x values. In an ordered pair, the x value is always listed first. X and then y, okay? So if you look at all your input values, they're all different. And they all have a different output. So the output when we input 1 is 2. The input is 2, the output is 3. The input is 3, the output is 4. So there's no repeating x values paired with two different outputs. Let's look at example number 2. If we underline the input, which is the x value, you will see that the number 1 appears twice. And since that 1 is paired with a 2 the first time, and then a 4 the second time, that's not a function. The 1, the input, can only be paired with a certain output. It could either be 2 or 4, but not both. It can't have two different outputs. Also, if you look at 2, the input of 2, it's paired with a 3 and a 6. It can't happen. If it happens that way, it's not a function, okay? Sometimes it's easier to list the domain and the range. The domain are your x values. The range are your y values. Okay, so we're using these ordered pairs up here, and we're listing the domain, all the x values for example 1. 1, 2, 3, 4, and 7. Yes, they were 1, 2, 3, 4, and 7. And then we list the range. You notice that each domain, the domain does not repeat, and it's not paired with the same two different outputs, okay, two different y values. In this case, you see the domain repeats, and it's paired with two different outputs. That means it's not a function. This is just two ways to present the information. One is the list of ordered pairs, and the other is just listing the domain and range. As you can see, the domain values in example 2 repeat. Okay, they repeat. Therefore, the relation is not a function. They repeat and they're matched with different outputs. Okay, the next way you can see functions presented is in tables. Okay, ordered pairs, domain and range, and tables. If you look at the x and y values in table 1, look at your x values. They're all different, and they're all paired with. They can be, as long as they're all different, it doesn't matter what their output or what they're paired with. It doesn't matter. They're all different. So that means this one is a function. Table 2 has input value that repeats. So 3 is paired to 6, the output is 6, and it's paired to 9. That means it's not a function. The 3 can't repeat to different outputs. Okay, table 2 has repeating x values with different y values, so it's not a function. Now let's look at another way to identify functions. Functions can be identified by the graph they produce. So these are 3 examples of coordinate planes. Let's pretend like these are coordinate planes. X and Y, right? You guys are familiar with those. The X is the side to side. The Y is the vertical. So this is your Y-axis, this is your X-axis. So there is this thing called the vertical line test. Well, vertical means up and down, okay? So if I can draw a line through this dark graphed line, like I did, I drew the purple line, right? And it hits it only one time, that means it's a function. Yes, it works. If I draw my purple line through this circle, it hits in 2 places, not a function. If I draw a line anywhere through this curved graph, this curved, looks like a roller coaster, it only will hit one time each time I draw a vertical line. So yes, it is a function. Okay? So if it hits more than once on that graph, on this graphed, let me pick a different color. On that circle, it hit twice. It only hits once. I could draw another purple line, and it's only going to hit one time. As long as it only touches one time, it's a function. So as you can see, when you're identifying functions, each input value can only have one output value. Okay? So look for repeating x values. If you see repeating x values and they're matched to 2 different outputs, like here and here, it's not a function. Okay? If you see that it doesn't pass the vertical line test, it's not a function. Okay, the function machine is an input, it's an input, output situation. Okay, its x values go in and the y values come out. It's the domain compared with the range. Okay, an ordered pair is a function. Another ordered pair that doesn't have the same x value is a function as well. Okay? A function is a rule, it's a rule with just one input and one output. Let me fill this in with you guys. Okay. Where is my... I'm looking for something really quick so I can help you fill this in. There it is. Okay. So a function is a rule, a mathematical rule with one or more inputs where each input, one or more x value, where each input has a single output. X value has one y value. X value, y value, input, output, there's only one, has a single, okay? Functions. Each blank is allowed to correspond to one blank. Each x value is allowed to correspond to one y value. Okay? That's the definition of function. Okay, let's talk about functions notation. sometimes you will see this, in place of y, you will see this f, looks like that, and then you'll see parentheses x. And it's pronounced f of x. F of x, okay? But that is put in place of y. So it's a function of x gives you y. Let's take a look at these two examples right here and right here and see if they are functions. So here's two tables. Let's look at example 1. This relation is a function because none of the input values, the x values, has more than one output value, the y value. So let's look at the input values. None of them repeat, so we automatically know that we have a function. All right, now example 2, look at your input values. Do you see how -3 showed up twice? And when it showed up twice in our table, it was matched to two different outputs. So it's not a function. Okay, that's why. To evaluate a function for a particular x value, just input and then simplify. So you're going to, for an x value, when you're evaluating a function, you plug it in. So you plug in that value, and simplify using order of operations. So they give you an example here. If f of x, which could be replaced with the letter y, equals 2x plus 1, and we know that x equals 3, see how they replaced x with 3? We take the 3 and we plug it in for x. So we do the calculation, the order of operations on the right side. 2 times 3 is 6, add 1, and that's 7. So y equals 7. So our little table would look like x is the input, y is the output, and we input 3 for x into this function, and we output 7. That's what we got when we did our computation on the right-hand side. Moving right along. Let's determine if a relation is a function. So real quick, let's talk about the word relation. A relation is a set of ordered pairs. Set of ordered pairs. Now, what do I mean by that? Okay? It's a set of ordered pairs. It just means that we have like ordered pairs like -3, 2, maybe -1, 0. Maybe we have like 5, 7. These are ordered pairs, and it's a set of ordered pairs. So I'll put set notation around it. All right? So those are just ordered pairs. They're just dots on a coordinate plane. We've graphed them on a coordinate plane. You know, like you could graph all these ordered pairs on this coordinate plane. -3, 2 would be somewhere over here, and -1, 0 would be right on the axis right there, and then 5, 7 would be somewhere way up here. Okay, but these are all ordered pairs. That's relation. A relation is just a set of ordered pairs. All right. So sometimes we get a table to look at. This is a table. And we have to determine if this table is a function. So review the columns, the x and the y, the x column and the y column. The relation will not be a function if any x value corresponds to more than one different y value. So let's take a look. Let's look over here. So we have -1 is mapped or corresponds to 1. 0 is corresponding to 0. And 1 is corresponding to 1. All three of these x values are different, therefore we have a function. Okay? Set notation. Review each ordered pair. So a set notation I explained up top was just, if we look up top again, is a set of ordered pairs. I have set notation right here with this set of ordered pairs. So we get to look at the ordered pairs and focus on the x value. Set notation. Review each ordered pair. The relation will not be a function if any x values. So again, the x value or coordinate, x coordinate, corresponds to more than one different y value. So again, let's check it out. All right, so here's our set of ordered pairs. Okay, now we're going to focus on all our x values, 3, 4, and 2. They're all different. So we have, since they're all different, they're paired with different numbers, we have a function. That is considered a function. Okay, if we added another ordered pair to this set, like let's say we added 3, -5. Well then, we do notice that 3 showed up twice. So, and it corresponds to 3 and -5, so it wouldn't be a function. So let's look at example D. Let's focus on our x values in this set of ordered pairs, which would be 1, 0, and 1. Uh-oh. 1 shows up twice and it's paired with 8, and then the next time it's paired with -3. So that's not a function. So that would be a no. This one would be a yes. Let's go back up to the top. I forgot to do B. This is yes. This table, B, letter B, let's look at the x values. 3, 0, 3. Uh-oh. 3 shows up twice and it's paired to -6 and +6. So that one is not a function. Can't have 2 3s and they're paired to different numbers. The next way we look at functions is using the graph. Okay? Use the graph. Use the picture. The relation will not be a function if a vertical line ever touches the graph twice. More than once. Because it could touch 3 times. More than once. If it touches more than once, it's not a function. All right? Okay, so let's look at E and F. So let's look at letter E. Let's look at this graph they give us. All right, letter E, they gave us this graph, this U-shaped kind of graph on the coordinate plane. And if I do my vertical line, boom, I only hit one time. Each time I draw a vertical line, I only hit one time. So that one would be a function. Now if we look at our graph in letter F, and we draw our vertical line, it hits twice. So that is not a function. The next way we look at a relation to see if it's a function is the map. We use what's called a mapping diagram. Review the arrows. The relation will not be a function if any x value maps to more than one different y value. So let's look at the examples. All right, this is called mapping right here. And as you can see, these are your x values, these are your y values. All right, what I do is I focus on the arrows coming off of these inputs, the x values. If there's only one arrow coming off of each number, then we have a function. If we look at the next example, we have 2 arrows coming off of 3. You cannot have 2 outputs for one input, so this is not a function. And lastly, let's talk about domain and range. The domain is the set of all possible input values. The range is the set of all possible output values. Input are your x values, range or output are your y values. Identify the domain and range of the relations in the table, set notation, and graph examples above. So in this situation, I'm going to look at my table, which was A and B, and then I'm going to look at my set notation, which was C and D, and I'm going to look at my graph, which was E and F, okay? And I'm going to identify the domain and range of each one. So it's pretty easy in letter A. It's -1, 0, and 1. So in this, I would put, for letter A, the domain is -1, 0, and 1. And the range for letter A was 1, 0, 1, 0, 1. So that's my y value. So I put 1, 0, 1. Okay, the only difficult one here to really see is E and F. So I'm going to go down to E and F. Letter E is asking you for the domain, which is all the x values. So if this graph kept going on and on and on, all the x values on this graph is all real numbers. It's everything on the x-axis, all real numbers. So letter E would be all real on x-axis. And the range for letter E would be the y values, which starts right here. It looks like -1 and goes up. So it'd be all the y values greater than or equal to, the y values greater than or equal to -1. There's a notation that I will teach you as well how to write this. So letter F is not a function, but the x values start right here and go to the right. So that looks like it's -1, -2, -3, and everything greater than -3. So this would be all reals greater than or equal to -3 on the x-axis, x values. And the y values keep expanding, so they include all real numbers. So the y values are all reals, all real numbers. Okay, and here's a little try it. You can create your own function by putting numbers in x and numbers in y and then graphing it, drawing the line or however you want it to look, wherever these end up.